OK 得唔得？咁我又繼續 share 個 screen 喎，好冇？Okay, so now let's try another examples based on the quadratic function. Okay, so I'm trying to clear some of the objects here. I just simply delete them. Okay, I start from the beginning. Okay, so this is the basic quadratic graph. Right, I just put it as a function f of x equal to x squared. Okay, and so remember we can always put a point. And now this is the manual for geometric constructions. Okay. And you can find, and the basic object is a point. So you can choose to create a free point, just like this, and use the move mode again. So this point A is movable. And on the graph, okay, if you click on it here, then it will stick to the graph. Okay, can you see the difference? Right? And in fact, you can also, let me just cancel this point. You can also turn the point A to be a point on a graph or on other objects. So let's try to put it here. Let me see. Oh, there's no such option. I think something wrong with it. Okay, so I can choose the attach or detach point. Okay, tools here. In order to put the point on some objects. Okay, for example, in this case, I choose this point A and then choose this curve. Then the point will be fixed. So if you right click it and see the object properties, then you can see now the point A is a point on F. All right, so that is the way you input it. If you use the input bar, then you can also do the same. Okay, let A be the point on F. All right, so these are also the syntax as well. Okay, can you follow? Okay. Similarly, I can put another point B on the curve. Then I have 2 points A and B. Okay, on the curve, and I can also join it by a segment or by a line. Depends on what you want to study or discuss with the student. Let's say if I join it by a segment, okay. Can you see this? Okay. Okay. So it looks like a chord, right, on the parabola. Or sometimes we'll discuss what happens if you put a line there, right, connecting 2 points on the parabola or on the quadratic graphs. Okay. Can you follow? Okay. Now, in my example here, I would also like to make the point B dependent on the point A. Okay. Now, point A and B are now separate points on the graph, on the same graph, although they are stick to the same graph, right? But they are independent. You can remove independently. But now I can change the definitions of point B. Okay, maybe I double click here. Oh, sorry. Yeah, it's better open the dialog box and then redefine it. Okay, and I can make it. Okay, I can specify the x coordinates of B to be x coordinates of A plus a number. It may be plus, let's say plus 4. Okay. So it will be 4 units to the right of the point A. Can you imagine? Right. Right. If I set it this way, and I continue to set the y coordinates of B. Okay. So the y coordinates of B will be f of this coordinate that I have just set. Okay, so this kind of syntax can be very useful because it helps you to connect the 2 points. Okay, now so point B will still be a point on the graph. Okay, can you see this? But it would be a point and 4 units to the right of the point A. Okay, now let's enter it. and see what happened? Do you know what I mean now? Can you follow? Okay. So B is 4 units to the right of A, and it's still on the curve. Okay. Can you get it so far? Do you understand? Okay. So if you want to, let's say, if you want to see clearly how A and B are separated horizontally, actually you can add some points here. For example, so if there is any background noise, you may mute your mic. Okay, perhaps it's okay. All right, thank you. Oh, so what I put down here? Oh, just undo it. Okay. Now I'm using the input bar below. Look at it. I'm now input the value, and now I will now to enter another point. So based on the x coordinates of A. Okay. So I can also enter it here. Then I will have a new point. The y coordinate is 0, so it will be stick to the x-axis. Okay. So now I can indicate a point on the x-axis, okay, corresponding to the point A. And similarly, I can also enter another point, B, using the coordinates of B, and put it on the x-axis. Okay, can you understand the syntax here I use? Okay, if I enter it, then you will have 2 points, okay, on the x-axis, corresponding to A and B. And now you can also join it by another segment, okay, through A to C, B to D, okay. But maybe you can turn them to another color to distinguish them and also make it a dotted line, and it may be better, okay. So what I'm doing is that I add 2 points in order to indicate how A and B are separated by the same distance, constant distance horizontally. Right. Okay, can you follow? Is that okay? Now, the next step I like to do will be at the third point on the graph, which is the midpoint, which is corresponding to the midpoint between A and B. Okay, so imagine that if you put a point here between C and D, okay, and then you go up to the graph, then what would it be? Okay, so if you want to do it in a few steps, it may be better because actually it will include a very long expressions. Okay, so let's check. Let's say I set h equals to the average, okay, of A and B, x coordinate. Can you see what I input here? I set a number h. Okay, I define a number h, which is the average of x coordinate of A and x coordinate of B. All right. And now this is a number which is not shown on the graph, right? It's just a number, okay, which is the average of x of A and x of B. All right. But based on this h, I can set another point, which is f of h. Okay, can you see what I put down there? Let me see. I have to change this. Well, I can't see the participant. Oh, the participant list is here. Is anyone entering? No? Okay, I go back. All right. Sorry, have I input the function? No, not yet. Oh, yes, here, the point E. Okay, point E is the third point, the other point on the graph I add. Can you see the properties? This is the point F. So that means point E is always halfway between A and B, right, horizontally, but it's still on the graph, okay? Can you follow it? Okay. Now, finally, I like to join it to make a triangle. Okay. Okay, can you see the point? Maybe I now can hide point C and point D. You can always hide and show points or objects, okay, on this algebra window just by clicking the dot. It's quite easy. And also the line, perhaps I can also hide it. Okay, can you follow? Okay. So what is the area of this triangle ABE now? Can you see this? Is it easy to calculate? Right? So let's also use the algebra tool to do the calculation. You can see a list of measurement here: area, length, or slope, or angle. These are measurements. Right? You can measure objects here. So I measure area. So I click this one and then select the triangle. Okay, and you will see the triangle area of triangle AEB is equal to 8. Is it correct? All right. Now, if I move point A to the right, what will happen to the triangle? Will the triangle area increase or decrease? What do you think? Any guess? If I move triangle A to the right, okay, what will happen? Now, if I ask a student, maybe I can hide this one. For example, I can hide it. Okay, and also, yeah, so you see, you don't see the value here, right? But I can ask the student, now this is what I mean. If I move it to the right, is it greater than 8 or smaller than 8? Any suggestions from you? Do you have any idea? So let's see what it is. Okay, what do you notice? Okay. Is anything wrong? The triangle areas is just the same. Okay, maybe let you further explore. Okay, why the area is not changed in this way. Okay, and is it easy to calculate the area of this triangle? Any idea from you? Maybe another question for you, okay, as a homework. You can try to find out the area of triangle, and you can further ask, can our secondary 5 or 6 students calculate the area of this triangle? What method can they use? Okay, so maybe you can have a try, okay? And I can give you one more step, right, perhaps. I think the midpoint of AB could be useful, okay? So now to plot the midpoint of AB is very easy because I don't have to separate X and Y coordinate. I simply put A plus B divided by 2. Can you follow me? A plus B divided by 2. I'm input, okay, the point like a vector. Do you understand? I just directly put A plus B divided by 2. Then I will get the midpoint of A and B, okay? It's just like the operations of vectors. Can you follow? Okay. So just enter, then you can see the point F. Okay. F is the, if you click on it, it is A plus B over 2. All right. And so if you join F and E, would it help? Okay? You can leave it as a hint. Okay. Let's say if you want the student to see this part later, okay, now you can hide it. So the hide show button, let me check. It can be found somewhere here. No, I should get the checkbox. Am I right? Yes, I should check checkbox. Okay, pay attention to this one. The checkbox will help you to hide or show certain elements on the graph. So that means if you add a checkbox, okay, let's say you can say, I just name it anything I like. It's called caption. Okay, I call it a hint. Okay, I will give a hint later. And this hint is actually showing the segment I add here. So maybe I like to go on to show that this is the point F. And then the segment, the last segment I draw, I think is FE. Can you see this? Okay. And then that means these two objects will be controlled by this checkbox. If I add apply, okay, if I click apply here, then I will have a checkbox here. You can right click to drag it. All right. And then, so you can see the area. Understand? Right. So that means you can first demonstrate the triangle and show the area, and then later on open or show the hints if you want to further discuss how the area can be found. Of course, after showing FE doesn't mean it's immediately obvious how to find the area. Right? You still have to go to consider the next step. Okay, I mean particularly using the tools that the methods that Form 5 or Form 6 students can use, or even earlier form actually, right? Can find out the area. I leave it for you. But now this is the use of button, okay, and some kind of checkbox for you to prepare some material on the screen that can be shown or hide at any time you like. Okay, can you follow? And how about if I modify the point, okay? Now, because, for example, this graph, okay, is based on f of equal to x squared, f of x equal to x squared, okay? If I change it to, let's say, 2x squared, what would the areas be now? Can you imagine if I change it to 2x squared? All right, now this is the things you can further explore, all right? How this area is depending on the function coefficients, right? Or if you move it around, okay, I move it down or up or down, okay, it may be not easy to see. By the way, maybe it's better to change it to 1/2. Then it will be easier to see. Okay, do you notice that? All right. So it's quite dynamic as a whole because you can change any part you like. Once you define clearly the relations among the objects, of course, don't forget that A, B, and C are defined by the input here, all right, so that they always follow the function f. Understand? That's why when I change the function f, it will be confined to the same objects, right, in the same way. Okay? So when you construct a figure, you will think of beforehand, right? What kind of relation you want to define among the objects. Do you understand? Right. Of course, with more practice, then you can be more familiar with this process, right? Or designing the relation among the different objects on the screen. Okay. All right. Let me see what else I can vary. Maybe I can also vary the relation between A and B. Right? If you look at this, B is now always 4 units to the right of the point A. You understand? Horizontally, okay, it's just 4 units. Now I can turn it to another constant that I can vary, okay? So that, for example, I can add a number. I can do it in several ways. I can input a constant k equals to 3, for example. Okay, I have a number here. This is a number. Okay, And if I show it on the screen, it becomes a slider. Do you notice that? It becomes a slider, all right? And for a slider, you can control its property, okay? So it can be, let's say, from 0 to 5, and then you can decide the increment, or maybe the increment is 1, right? Okay. Now that, so that k will become a number, an integer, right, from 0 to 5. Do you understand? Okay. And with a slider, you can use it to control and the parameter. For example, you can control the functions of f. Or in my case, I would like to make it, okay, related to the function to the point b. So I now turn it to f. Okay, so all these are depending on k. Okay, so b is now k units to the right, okay, and apply it. So you can see I can make it wider or shorter. So you know what happened to the area. Okay, if you can further explore, right, in what way the distance, okay, control the area of the triangle, but independent of the position of the point A, actually, okay. So if I slide the point A anywhere on the graph, you get the same area. All right. So you can play around with this, all right. And the hints, don't forget the hint is still there. All right, you can click on this again. Now, maybe one more point about the graph paper. You can see that some options are shown here above. You can show the grid or hide the grid, okay? Or you can also show the axis or hide the axis. Sometimes if you hide everything, it's just like a piece of blank paper, right? But if you turn it on, then you can see the axis. All these can be further adjusted, actually, okay? If you right-click on the paper, and then you can choose the graphic properties, right? Then you can control, let's say, the major and minor grids, okay, the distance between them. Okay, you can explore, right, how these options will help you to adjust or reformat the graph paper. All right. So is it clear to you? Any questions so far? Do you have any question about this example? Okay. Tell us how you solve this problem, right, later on when you solve it. All right. You share with us how you understand this problem or how you further develop this problem, if you like. Okay. Well, then, how about we turn to geometry? And do you like to try some examples in geometry? Okay. All right. Then I maybe just close this graph. All right. I close this graph now, and then open it again, perhaps. Sorry, I should use the GeoGebra 5, Classic 5. Okay. Now I'm using the version GeoGebra Classic 5 again. Okay. But this time, are you following me? All right. So if I turn off the graph paper axis, then I have a blank paper. Okay. And with a blank paper, you can also use the input field to enter points or any other objects you like. Or you can start directly from the menus above or for geometric constructions. Okay. Okay, can you follow? Now, some maybe basic construction you can try here is that you have a triangle. You can create a triangle by 3 segments connected together. All right, so this is 1 segment. And then you click B again, all right, to create another segment. And then you click C and then go back to point A, okay? Then you have 3 connected segments. Right? Of course, you can draw 3 separated segments as well. Okay? But now I try to connect them so that it looks like you have a triangle on a piece of paper. And on the left, on the algebra field, you will see the vertices A, B, and C are just 3 points. Okay, and then additionally, you have the segment F, G, and H. Actually, each of these objects have its name. Right? So if you click on this, this is the segment F. Right? And in fact, you can show the label. Okay, if you like, you can show the label. Can you see this? Okay. Or if you want to do more, just double click it and you can see the, now you can see a definition, segment connecting A and B. This is the definition. And, or you can further open the object dialog box or property. And for the segment F, and you can shows the name and value or just the value. Value here means the length of the segment. Of course, depends on what segments you have, so what objects you have. Okay, if you are looking at the polygon, okay, then the value means the area of the polygon, something like this. Okay, so you can try it out. If you turn the value, then it will show the value. That means it will show the length directly. That is the easier way to indicate length on the graph, actually on the GeoGebra windows. Is that okay? Right. So if you right click it, then you can also choose to hide the label, right? But you are not hiding the segment. So do you have any question? Now let's try some other construction, okay? And if you want a perpendicular line or parallel line, you can consider this tools on this list. For example, a parallel line. So for example, a parallel line, you can draw a line parallel to BC and through A. I just click BC and then the point A. Okay. In that case, then I will obtain a line through A and always parallel to BC. Okay. Now, similarly, you can also construct a perpendicular line. Okay. Perpendicular to the point to the line BC and through the point A. Okay. So in this way, you will have a line perpendicular to the base BC. Right? All right, I just clear this, I just delete it. If you understand what I'm doing. And here are some other more useful construction. For example, angle bisector or perpendicular bisector. Right? Now, particularly the perpendicular bisector. If you select this one, then you can click on any line segment or pair of points. All right. Let's say if I click on the segment AB, then I have the perpendicular bisectors of AB. So you can try to drag it to see. It is always the perpendicular bisector of AB. Right? You can also change the color to indicate it clearly. All right, can you see this one? And similarly, you can also continue to do the perpendicular bisector of AC. Okay? And you can also change the color. And now for the two perpendicular bisector, we can indicate the intersection. Right? So you can just add the point directly on the lines. I mean at the intersection, right, to create the intersection point. Or you can, of course, use the tool intersect, but most of the time I may not use this tool. Okay? But if you want to be more formal, then you can use the intercept tools to obtain the intersections of the two lines. Right? Now, otherwise, you can just try the point A, 3 point, but put it in exactly in the intersection. Okay? If it is correct, then the point D is always the intersection of the two line segments. Right? Actually, if you double click the point D, then you can see it is called intersect I and J, the segment I and J. Okay. Okay, can you see what I'm doing? Right. Now, let me ask you a question again. If I drag the point A, what happened to the point D? How the point D moves on the screen while I'm dragging the point A freely? What would you say? How we describe the point D while you see I drag the point A freely on the screen? Or maybe you can type in the chat area to tell us what you think. So any suggestions? I'll do it again. Let's see whether you can observe. I just freely drag the point A, all right? I'm moving the point A very freely. What happened to the point D? How does the point D move? Well, you should have a try. Anyone can tell me what you see? How I put the question this way, now I can change the question, okay? If I move the point A to the right, okay? If I move the point A to the right, what happened to the point D? Can you predict? If I now move the point A horizontally to the right, what happened to the point? What will happen to the point D? Any suggestions? So do you think the point D will move to the left or to the right if I move the point A to the right? Are you saying something? Try to unmute yourself first. You want to tell me? Yeah. So Bobby, what do you think? Huh? Any suggestions? What happened to the point D if I move the point A to the right?
And the point D will move to the left.
Ah, okay. So Frederick, what do you think?
I'm not so sure.
No, it's just fine. Just make a guess. At least let us know, right, how you imagine the figure.
I feel it will move leftward and a bit upward.
Okay, left and then up. All right, maybe. Anyone else will also share with us? I think you better have a try as well. Actually, it's not simply learning how to use the GeoGebra, right? But while you're using the GeoGebra, sometimes you come up with different kind of observation, predictions, or different way to describe it. Actually, I'm also sharing with you the way I handling the material on the screen, and even further develop into question for the student. You know what I mean? Okay, because not simply we are just clicking, dragging, drawing on your own on this computer, but now if you look at yourself as in the perspective of the teacher, right? You're always observing how the mathematical objects and relations are changing, varying, and this will lead to more naturally about your questions later on or your communication with students in the classroom. Do you see my point here? Okay, so all these can be interesting opportunity to try. Now let me show you. Thank you for trying. Okay, now observe carefully now. Can you tell me?
Moves upward.
Moves upward, right? Do you know why? So if can you remember the trace on function? All right, now it is useful again. All right, you turn on the trace, and then you can move it slowly. So actually, no matter how I move, D is always on a line. Okay. Can you explain it? What is that red line?
So it's a equivalent of BC.
Yes, it is the third perpendicular bisector of the triangle. Can you see that? Okay. Now, but I now turn to your one of the well-known property, because for you it should be well-known. All right, you should learn it already. Okay, but I turn it into another form, and to share an experience with you. Then you see the things in a different way. Right, but in fact you can also present it to the student, to let them observe and guess and also describe what it is, and go on to talk about perpendicular bisector. You understand? All right. So you can look for opportunities like this. So go back to some of your earlier suggestions or requests. What do you mean by making the things dynamic or interactive? All right. Sometimes it is actually some simple constructions, right? Then you start with, and then you discuss with the student, right? Not necessarily always very complicated constructions. Okay? Can you follow? Okay. So, but depends on how you pose the question, how you pick up useful opportunity to discuss things with the student. All right. So I leave you to further try and explore in this environment. I hope that you can find out more interesting things, perhaps, or on your own, and then come back to discuss with us. Okay. Now maybe I can turn to another example quickly. Now we have tried perpendicular bisector. Okay. And how about angle bisector? Any interesting thing we can talk about angle bisector, perhaps? So now for to make an angle bisector, you can mark an angle and then to construct the bisector. But first of all, you may also like to, construct the angle first. Okay. So let's say if you drag point BAC, right, then you will create an angle. Now, first of all, you create a new object, which is an angle. And at the same time, the measurement is shown, okay? But you can always modify it. If you double click it, right click it again, show the object properties. You can choose to display the angle name and value or just the value, right? Sometimes, I think usually you may not need the name, right? You just need the value, all right? And also you have to specify whether it is an angle between 0 and 360, or just between 0 and 180. I think most of the time you only need this, right? So you can specify it. Okay. And you see this one, all right? Now, so you can write you can create an angle, and then you can create an angle bisector, right? And so if you pick up the angle that by clicking the 3 points, then you will have an angle bisector. Right? So I can add a point here. Okay. And now you can hide this angle. So instead of showing this angle, maybe you want to show the two smaller angle, right, to indicate that the angle is being bisected. So now I go to click BAD and then DAC. I can see this. And here I can select all 3 angles at the same time and then edit all the properties at the same time. Maybe I show only the value. Okay. So in this case, I have 2 angles. But maybe you want to color it differently in order to indicate that they are different angles. Oh, sorry, I interchanged the 2. All right, so can you see how it works? Okay. Now here, once again, a simple question to the student is that now you see the angles are equal, right? I bisect the angle. How about the side BD and DC? Are they the same? Or is D the midpoint of BC? Okay. Can you see that? So you can ask the student, now this may not be trivial, particularly if BC is not horizontal. Okay. Then you can still ask a question. Do you think BD is equal to DC or D is the midpoint of BC? Right. So that is also related to a fundamental properties about isosceles triangle. Right. The student should know. But in the textbook, you won't easily present in this form, right, to discuss with the student. Okay. But this can be a question that you can ask the student. Right? Just like what I asked you to do, predict. Okay, make a guess before I move. For example, if I move point A to the right, do you think D will move to the left or right? Okay, it can be questions like this again. Okay, and do you think the distance will be different? Of course, this time it will actually be different. Okay, and if you check the measurement box, yes, I can check distance. So I can do it with measurement. So you can see the length. Perhaps the next question is, when will the segments BD and DC equal? Okay, that means when will the angle bisector also bisect the opposite side of the triangle? Can you follow me? Now this can be my question. Okay, under what condition the angle bisector will bisect the opposite side of that triangle? Okay, and this can be a question for students to explore, to verify, or to prove. Right? Or you can even try yourself, right? How you can describe it, how you can share or explain or communicate with the students about these properties or relations. Is it okay? Right? So in fact, while doing so, you may want to also add an angle. Okay. Now this is the angle delta. Okay. So now you see what happened if you make it an angle 0 between 0 and 360. It can be a reflex angle, right? But usually we would like to make it within the straight angle. Okay, and you can observe. Now it's a bit messy here. Right? Of course, if you want to discuss all these relations, then you may have to plan it a little bit better, right? So that it can be shown to the student much easily, more easily. Right? But the basic idea is like this. All right. Now maybe one more final question to you. You can draw circle. Circle is also very useful and common. All right. You can check here in what way you can draw circle. Okay. So that is a circle defined by center and the 3 points that control the size of the circle. Okay. And remember, I showed you earlier the detach and attach tool. So you can attach the point A to the circle, the point B to the circle as well, and the point C. Then the whole thing, right, now it will be on the circle. Can you see this one? Okay, one final question to you. Can you see the arc BG and the arc GC? Can you see this? Now, if I move the point A to the right, that means on this side, okay, I move the point A to the right, down the circle. What happened to these two arcs? Will the point G move to the left or right? If I drag the point A to the right, along this path, what will happen to the point G? Will point G move to the left or to the right? What do you think? Remember, AG is still the angle bisector of angle A. Okay. Then what's your guess? You can put it in the chat area. Now this is a final question for you today.
I think the proportion does not change.
Okay, so that means the point G will not change. Yeah. Okay. Yes, do you agree? Yeah, so you have a try. Do you see that? Okay. So that can be, once again, some question that you can easily pose to students. Of course, that will relate to Form 4 circle geometry. Okay. And so as far as you can identify some important elements of relation to be discussed, to be shared with the student, then it could be a piece of useful material in the classroom, right? You see my point, right? And it need not be a very complicated one. Although, of course, later on, you can also learn more skills or technique and further develop more complicated constructions. Right? But even at the beginning, when you do something simpler, it can still be useful in the classroom. All right. So go on to have a try. All right, continue. I think it's more or less the time today. Okay?